So the first thing I want to prove or disprove is, let's make a claim here. So my claim is that n squared plus n is even for all integer n. And let's go ahead and write that all nice and formally real quick. How would you write this statement formally? First of all, is it an existential or for all statement?
Universal.
Oh, fancy words, Safa. Good job for being formal. So, what? For all n and what?
Even integers or
No, for all integer n, no?
For all integer n, right? So we're saying that n squared plus n is even for all integer n. So even or odd integers, this should work. Right? So even is describing what the result of n squared plus n will be, not what n is. So for all n in the integers, n squared plus n is even. It's formal. I can do better for all. And I'll give it a black tie because it's formal. There we go. Very nice. So yes, so here's the claim. We always write it formally. It's a really good idea of going on. What do you guys think? Let's do an aside. And aside is just scratch work. It's a fancy name for scratch work. Let's do some scratch work. Do you guys think this is true or false? No idea? Well, let's do some examples, right? Someone pick an integer. Give me any integer.
1.
Oh, okay, we have chat. What about 0? Let's try 0. Good integer, Justice, one of the best. 0 squared plus 0 equals 0. And 0 is even. Why is it even? It's even because it equals 2 times 0, which is the definition of being even. 2 times some integer. So it works for 0. Who's got another integer? Let's try something else. Come on. This is the fun part of class. Try to mess this up. Try to find something. 5. I like it, Georgia. 5 squared plus 5 is 25 plus 5. 30, even number. Why? Because it's 2 times 15. And 15 is an integer. It works for 2. Why not? Let's do something weird. Let's try a big one. Let's see if it fails. Let's try like, okay, I don't know that many squares. So let's try, let's see, 101 squared plus 101. What's that going to be? 101, that's 100 plus 1 squared plus 101, which is going to be 10,000 plus 200 plus 1 plus 101, which is going to be 10,000 plus 301, 10,000, oh, plus 1, I forgot the 1. So plus 201 plus 101, it's going to be 10,302, which is even. Or you can use a calculator. The point is, we're getting a lot of even numbers here, right? So maybe it's true. Possibly your whole 2 to the n minus one thing on the homework has scarred you into not trusting examples, which is good. And examples aren't proofs, right? But maybe we can prove this. So let's think about it. Right, but before we start a proof, we should always kind of know why it might work. So let's look at n squared plus n. So a good problem-solving technique, right? Anytime you're trying to solve any problem, this goes way beyond this class. Right now we're learning life skills here, right? You thought I was teaching you math. I'm secretly teaching you life, even though like some of you are older than me. But the point is, a great problem-solving technique for anything in life is to simplify the problem, right? Like right now we're trying to prove it for all integer n. Let's scale that back a little bit, right? What's maybe a more manageable goal than every integer? See, Benet says let your computer brute force it, but here's the problem, Benet. You can't brute force infinity, right? No chat after that, huh? Silence, Benet. Get very close. So what's a more manageable goal than proving this for all integers?
Like 1 to 100 or something? Or
We can do 1 to 100, but then we're gonna kind of, then that's where a computer can come in, right? But even if we prove for 1 to 100, we're still kind of infinitely many off. That's a good place to start, though. We could do that. Proving some property. What if instead of all integers n? I mean, we're trying to prove that n squared plus n is even. Maybe we look at, what if we just try for all integers n? Or for all even integers n. So that's probably gonna come back. So let's see. What if n is even? Right? It's a little more manageable. If n's even, then there exists a k, and we have to be formal here, it's not proving anything. There exists a k such that n equals 2k, right? So n squared plus n is going to be 2k squared plus 2k, right? Which equals, let's see, this is going to be 4, or this will be 2 squared k squared plus 2k, which is 4k squared plus 2k. Does this look even?
yes,
Why? Yeah, why you said that, Toru?
because multiplying anything by 4 or 2 will always give you an even number.
Yeah, exactly. Because the definition of being even is that you can be written as 2 times an integer. 2 times any, it's just some integer. And so what if we factor out 2 here? We can factor out 2, and we get 2 times k squared plus k, meaning it's even. Although we need to be a little bit careful here, right? Because you can factor 2 out of anything, right? Like 3 equals 2 times 1.5. So why is 3 not even, but I'm saying this number is even?
Because integers don't include half numbers.
Yeah, exactly.
means
Because
argument
the
limited.
thing 2 being multiplied here is not an integer. While this thing is gonna be an integer. It's just 2 times an integer squared, because k is an integer. I should have said. And then that's gonna be integer plus k is an integer. So it's all integers. It's gonna stay in the family. Right? So this is even. So if n is even, n squared plus n is gonna be even. Right? That wasn't that bad, right? So what do we have left?
The odds.
Odds, right? What if n is odd? Well, if n is odd, the definition of odd says that n equals 2k plus 1 for some k in z. So for some integer k, n equals 2k plus 1. Then n squared plus n, that's going to be 2k plus 1 squared plus 2k plus 1. Notice, however, though, we could FOIL this out, but by our thing we did last class, and the square of any odd number is another odd number, this is going to be odd. So this is going to equal 2 times some c, I'll call it, plus 1, plus 2k plus 1. I'm not leaving all the steps in. We'll do that in the actual proof. And then this is going to be 2c plus 2k plus 2. Is this even?
Yep.
Yeah.
Yes.
Let's factor out that c plus k plus 1. These are all integers. This is an integer. Thus even. Boom. That's the idea. Does that make sense? And that's kind of neat. This is the idea to show that n squared plus n is even for all integer n. Let's not get too excited yet, because sometimes when you do scratch work, you don't show all of your work and you end up not being right. Sometimes people show a lot of work. Like there's one guy put out like a 400, 500, 600 page research paper, right? Proving something called the ABC conjecture, or something like that, I think. And anyway, it was really dense. Like only like a few people in the world could understand what he was even talking about. And even they had trouble checking it to see if he was right. It was taking them forever. And then while they were checking it, some guy came out with a counterexample and showed that actually what he was trying to prove correct was actually false. The point is, details matter. Don't be that guy. Put your work out in increments. But anyway,